Ladies and gentlemen, welcome to the review session, the first review session for the midterm exam. Well, just like probably you guess, this review session is for you to get a little bit acquainted with what's the midterm exam all about, starting tonight at midnight. So let me tell you a bit about the procedure before I tell you about the exam. You will receive at midnight an email from me with the exact instructions on how to take care of this exam. You will see exactly how to send it back to me via email. But anyway, just wait for my email at midnight. Now let me just get started and show you what the exam would look like. So the exam, just like I told you, will look like this. So look at this. So this is the midterm exam. So in fact, today I would like to discuss the midterm exam from last fall. And since I want to do that first, I don't know how long it will take, maybe an hour or a little bit more. So I'd like to tell you a bit more. So this is how the exam would look like. So this is the front page, you see? So let me start with the following. As you can see here, this will be posted on my webpage, on my teaching page. You will receive my email with precise instructions and also with the link of the exam. So, as you can see on the left-hand side, you will have the name of the course, Math 1451, twice. I don't know why, but anyway. Of course, this will be the midterm exam. You also will have a date and the time limit. Well, I put here to be just enough time to finish it, but it will be 48 hours. And this will be plenty of time to finish the exam. Also, make sure you write your name here. So here where it says your name, make sure you write your name. Because I need to know who I'm grading, whose exam I'm grading. And now let's get to the details a bit. So your name here. So let's get to the details. Well, the exam will consist of 6 pages, including the front cover page, and it will you will have 5 questions. So there will be 5 questions you need to answer, and the total amount of points one can obtain, since each question is worth 6%, the total amount of points that one can obtain is 30, as you can see here. And as you can see, I have this grade table here, right? For me, I will put the grades here. Well, usually I won't put it because since it will be an online take-home exam, I will just I will put it directly. I will put the final grade directly into Blackboard, and you will see it there. And then, if you feel unsatisfied with the grade that you got, you can negotiate with me. But anyway, you will receive precise instructions on how to send back the exam to me, and based on that email, it will be on the email. I will grade it right there. So there is no way for the exam to be lost unless you send it to the wrong email. So make sure you don't do that. All right, so as you can see here, there are, like I said, 5 questions. Each is worth 6%. Of course, since this is an online take-home exam, I will not award any extra credit question. I used to do that in the past, but not anymore. Also, I would like you to not post this exam on Chegg, or not to collaborate with each other. Anyone who has the suspicion of doing that will have his exam or her exam null. So this is on your own. It's an open book exam. You can look for whatever notes, whatever videos you want, whatever practice problems you want, or anything that I sent you, but please do not collaborate with each other. And I would like to stress that again. Please take the exam as serious as possible. Do not post anything on check. Like I said, anybody who posts anything on check, of course, I cannot catch the person who did this. Well, although if I try hard enough, I could. But if I see one question posted on check, everybody will get a 0 on that question because I cannot catch the person who did it. So I have to penalize everybody. So be responsible. That's the only thing I'm asking you to for this exam. It's not going to be a hard exam. It's going to be like a fair exam. And we will see now, once we go over the questions, you will see exactly what do I mean by that. And what can I say? I'll wish you good luck. So this is how the exam will look like. All right, now let's get to the questions of these exams. So let me show you this first question that I would like to discuss with you. And I will give you, since you have the exam tomorrow, I would like you to think of these for a little bit, and then we'll discuss them. So the first question reads as the following. And like I said, this is 6 points, is worth 6 points. Right, it's 6% of your final grade, wow. So evaluate the following limits or show that they do not exist. So the first one is the limit as x approaches 0 of sine of 2x over x. And the second one is the limit as x approaches 0 of the square root of x squared plus 4 minus 2, everything over x. Okay, so think about this problem for a bit, and then we'll discuss. Oh, give me 1 second. Okay. So let's see the first one. How would you approach the first one? I want to hear some ideas. So if we plug in x0, what do we get? It says here somebody, well, the first one, you say that it doesn't exist. Not quite. Think about it. So sine of 0 is 1 if we plug it in. We'll see somebody already. Okay, wow, 2. So let's see. So I see some people say it doesn't exist. Some people say it's 2. Anyway, let's see some other opinions. What do you think? Oh my. All right, let's see. So if we plug in x0, what do we get? So the limit So we have that the limit as x approaches 0. So let's plug in directly. Sine of 2x over x. This will be what? Can you tell me? It's 0 over 0, correct. So the 0 over 0 is what? It's indeterminate, right? So we need to do something about it. So does this ring a bell? Is there a limit that we discussed over and over again during our lectures? And you have seen it. And I told you this is a fundamental trigonometric limit. Do you remember something? Does this ring a bell to you? So sine of 2x over x. Was this when you have sine? Do you remember something? So let us recall the fundamental limit. And this was what? Is the limit as u, let's say, approaches 0 of sine of u over u equals 1. Remember this? We've done this and we've talked about this over and over again. So that's the fundamental limit that we would like to use in this case, right? So what should we do? Maybe in our case, u will be 2x, right? So in our case, u is 2x. So we have that the limit as x approaches x, as u approaches 0, 2x will approach 0, so x will approach 0. So we'll have that the limit as x approaches 0 of sine of 2x over 2x is 1. Okay, so we have this. Now the only thing we need to do is just to write our limit as in terms of this limit right here. So we want to write our limit in terms of this one here. So we want, let's write it here, we want to write our limit as, so let's write it. So we write this lim as x approaches 0 of what? Of sine of 2x over x. And this would be, and I want you to be very careful here because I would like to write this limit in terms of the limit okay, in terms of the limit, sorry about that. In terms of the limit that it's in green, right? So I'll write this as, so let's do it. Let me emphasize this. Lim as x approaches 0 of sine of 2x over 2x, and let me put it like this, times what? Times what's left here? The limit as x approaches 0 of what? Can you tell me? I multiply this by what? By the constant 2, right? And this guy here, this limit will be 1. So this guy here approaches 1. And what is the limit of this guy here? So the limit as x approaches 2 of 2, sorry, the limit as x approaches 0 of constant 2 is what? 2, correct. So this would be 1 times 2, which is 2, indeed, which somebody said right here. Okay, is that clear for everybody what we do? So you should expect something similar at the exam. Okay, any questions so far about this one? No questions? Okay, if there are no questions, then I will assume that everybody understood perfectly what's happening here. Okay, I hope this will be confirmed at the exam. Okay, let's see. There is a question actually, which is great. You see the 2 here. So why did we get the 2? Look, because I have that sine of 2x over x. It is sine of 2x over 2x times 2, right? You see? Without even putting the limit, yes, we only have this expression. So the 2 will cancel and you will get exactly this. Does this make sense now? Diego? Well, I would like to write this. Look here. I would like to write this in terms of. So this is. Look, let me. Sine of 2x over x will be sine of 2x over 2x times 2. So I'll write it in this way. So I'm putting 2x here because I would like to have the same quantity inside the sign and outside and here, because I would like to use this limit right here. You see? Sine of u over u. So in our case, u is 2x, just like I said here. Does it make sense now? Brian, Diego, is it clear? And others?
Yes.
Okay, great. All right, I'm glad that we have questions now. Now we're talking. That's the way I like it. Let's see, any other questions regarding this first one? No? Okay, if not, let's move to the second one. Okay, let's see, another question. So what if the x in the bottom was like a 3? Well, if it was like a 3, right? Let's just, for example, if it was something like this, the lim as x approaches 0 of sine of 2x over 3, right? That's what you're asking? All right, so no problem. You just plug it in directly, sine of 2x. So that's the first thing that you do. You plug in x to be 0. You want to see what kind of indeterminate do you have. But in this case, sine of 0 will be 0 over 3, which is 0. So there is no point of invoking any limit involving sine. It's just direct. You can do it directly. You can plug it in. Maybe you could ask, what if it was something like 3x here? Something like this, right? In fact, what is this limit equal to? So that's a question you can answer, right? And you can do the same trick, right? Okay, let's actually do this. What if we can modify this limit? Yes, we can do that. You can use this fundamental, so we can use the fundamental limit, just like you said. Yes, exactly. So exactly. So we can factor in this way. So we write the limit as x approaches 0 of sine of 2x over 3x. This will be, and let's write it in this way. So we, just like Eric said, we can write this as the fundamental limit. So this would be the lim as x approaches 0 of sine of 2x over 2x. And now I'm going to multiply by what's left. So I will multiply by what? Can you tell me? By what? By 3x, right? Really, by 3x? Really? Let's see. So let's write it here. Sine of 2x over 3x is, let's write it in this way, sine of 2x over 2x times what? Times what should I put here in this so that it would give me that? Can you tell me? Two over 3, correct, exactly. Exactly, so I put here 2 over 3. You see? So that's exactly, so I put here 2 over 3. Okay, so if we have this, then the limit will be what? So the limit will be equal to what? So this guy here will converge to what? Can you tell me? The limit of this is what? The limit as x approaches 0 sine of 2x over 2x is?
2.
1, correct, yes. And the limit of this guy right here, of the constant, will be what? Two over 3, correct. So the limit will be 2 over 3. See, the constant is a bit different. But anyway, and you can play around, you can modify this as much as you want. So anyway, I hope it's clear, this thing. So let's move to the second one. What about the second one? Look at it. So we have the limit as x approaches 0 of the square root of x squared plus 4 minus 2 over x. What can you tell me about this? So let's not. Okay. Let's look at this guy. And why would you say it would be just 0? Do we end up with 0 over? So let's see. You see, maybe you got something right, but you see, once you plug it in, the indeterminate, if we plug it in, x equals 0, so we'll have the square root of 4, which is 2, 2 minus 2 is 0, so we'll have 0 over 0. Keep that in mind. Just difference of squares. Be more specific. So what did we say about radicals? We said something about radicals. So Renee says we need to rationalize here. Exactly. So we need to rationalize. And how would we do that? So we need to rationalize the top, right? So I have a problem with the radical being here at the top. Exactly like Brian says, we need to multiply by the conjugate. So let's write it here. We multiply by the conjugate. Okay. So let's write it, and let me write it in this way. So let's not put any limit so far. Okay, let me write it here so we have, multiply by the conjugate. So we have the square root of x squared plus 4 minus 2 over x. So what is the conjugate of, and let me be more specific here, the conjugate of the square root of x squared plus 4 minus 2. So what is the conjugate of this guy here? So we're going to multiply by the conjugate. So what is that conjugate? Tell me.
The square root of x squared plus 4 plus 2.
Exactly, correct. Exactly, yes, correct. We changed negative 2 to plus 2, correct. So this will be the square root of x squared plus 4 plus 2. And let's see, what do we get? So this will be equal to, and let's write it here. So this will be the square root of x squared plus 4 plus 2 times the square root of x squared plus 4 minus 2, everything over x times the square root of x squared plus 4 plus 2. Okay, so what do we obtain at the top? Can you tell me? We have that difference of so what do we get? So at the bottom is quite clear what do we have. So we have this guy here. So x times the square root of x squared plus 4 plus 2. And on the top, let's see, do we get 1? Are you sure? 0. It's x squared. So we get what? We get x squared plus 4 minus 4, which will give us, so these two will go away, which will give us x squared over x times the square root of x squared plus 4 plus 2. Great. So x will cancel here. So this will be x over the square root of x squared plus 4 plus 2. All right, great. So we've done only algebra so far. We haven't done anything else. And now maybe we should just take the limit. So taking the limit as x approaches 0, what do we get? So let's see. So we get the limit as x approaches 0 of the square root of x squared plus 4 minus 2, everything over x. So the initial limit will turn out to be equal to, at the end of the day, with this guy right here, which is the limit as x approaches 0 of x over the square root of x squared plus 4 plus 2. And now, if we plug it in x to be 0, this will give us what? What do we get? Zero over 4, which will be 0. Wait, what? 9 over 4? 0 over 4, yes. Which is 0, and that's the answer. And that's the first exercise. You see? Was it hard? It wasn't, right? If you know the fundamental limits, so you should expect that. So make sure you use those. All right, let's see any questions regarding this second part, this second limit from the first. I want to hear questions about this one here. You see, why is it 4? When I plug it in, look. So as x approaches 0, the square root of x squared plus 4 plus 2 will approach what? So x is 0, you plug it in here, so you get, let me, just a second. So we will get what? You will get 0 squared plus 4 plus 2. So, which is the square root of 4 plus 2, which is 2 plus 2, which is 4. That's why we get 4 here. Let's see another question. Okay. So let's see another question by Eric. So for the conjugate, why do we only change the 2? For example, why not change the sign of the 4 instead? Yes, exactly. So the square root is a whole function. Yes, exactly. Exactly. So it's everything inside the square root. I didn't have something like square root of x squared plus 4 here. So it was, you see, I have it like this, it's inside, right? So that's why. Let's see, other questions. Is it clear, Eric? And everybody else? So let's see, go up. Up where? Up, up, up. How up? It's here. You see, it's inside the square root there. So it's the square root of x squared plus 4 minus 2. The red and the blue where? In the sign thing? Where exactly?
The limit of sine 2x over 2x and then limit of 2.
Yeah, we'll multiply this. You mean here, right?
Yeah.
Yes, we do multiply them, yes. So I can write them in this way. You see, this is a multiplication here. Right? Let's see, any other questions? Okay. If there are no other questions, so this is how one will look like. Let me show you number 2 then. Let's move to number 2. So let me read it, and I'll give you a couple of minutes to think of it. So we need to find 5 constants a and b such that the following function, as you can see below, is a piecewise function, such that the following function, f, is continuous for all x. And you need to justify your answer. So the function is given by the following. I want you to look at it. So it's f of x. We have 3 pieces right there. So the first piece is for x strictly less than 1. So it's, as you can see, I have those constants a and b. So it's x plus 3. At x equals 1, the function is 5. It's constant 5, and for values of x greater than 1, we have x squared plus b. So we need to find these a and b, right? Look at them here. So who is a? Who is b? So think about it. So let's see, what do you think? Let's look at our function. Well, Dylan went way ahead. Yes, you're right, Dylan. But before we go into that, there is some procedure going on. So let's see. You look at the function. There are 3 pieces right there. And I know that the function is not is continuous for all x. In particular, since it is continuous for all x, it will be continuous at what point? We do have a specific point in the definition of our function. What? 1.5? 1 and 5? Not. What is that point that we need to be specific? Just look at the function. Look at it here. What is that point that we need to look at in the definition of the function, right? So the function f is f defined on R and real value. When I say it's f is continuous for all x, I mean all real x. But if you look here, there is one particular point at x, and that particular point is what? X equals, what do you see in common here? 1, exactly. So since f is continuous for all x, so let's write this. For all x, it follows that f is continuous at the point x equals 1. So let's keep that in mind. Okay, and now let's recall the definition of continuity. Well, what does it mean for a function to be continuous at a point? So recall that f is continuous. So let me write this in this way. F is continuous at the point of x equals x naught, right? If what happens? Can you tell me? If and only if what? I want to hear. What's the definition of continuity? If and only if? You remember? The left-hand limit, the right-hand limit, and the value at that point, all three of them must agree. In other words, we have that the limit as x approaches x 0 minus, right? So this means that the limit as x approaches x naught, but with values of x less than x naught, right, is the same as the limit as x approaches x from the right, the right-hand limit of f of x, and these are the values x for which are greater than x naught, right? And this is also equal to, and let me write it in this way, the value of f of x naught. All right, so that's our definition. Ooch. So this is our definition. Now let's apply our definition in our specific case. So what do we get? Tell me. So in our case, f is continuous at 1. Of x naught equals 1 if and only if what? Can you tell me? If and only if what? Let's see. Yes, something like this. So if and only if the limit as x approaches 1 minus of f of x is the same as the limit as x approaches 1 plus, so 1 from the right of f of x, and is the same as f of 1. And now let's analyze each and every one of these. First of all, I would like you to tell me who is f of 1. Can you tell me this guy f of 1 is what? Equal to what? Can you tell me? If you look in, it's 5 exactly. We see it's right here. At x equals 1, this the value f of 1 is 5. Great. So we got rid of this. And now let's see each and every one of these. So what about this limit here? This will be the limit as x approaches 1 from the left. And f of x will be what? Can you tell me? So for values x of x less than 1, I will replace f of x by what function? What piece? Look inside the function and tell me which one, or which piece corresponds to value to values x less than 1. Indeed, it's ax plus 3. Correct. And this limit will be equal to, can you tell me? Let's go further. The limit as x approaches 1 minus as of ax plus 3 will be what? It is equal to what? Say it, come on. It's a times 1 plus 3. So a times 1 plus 3. All right, great. So I got this here. All right, let's move on this one here. What about this one? What is the limit as x approaches 1 from the right of f of x? Will be equal to what? So this is the limit as x approaches 1 from the right. Oh, and I'll replace f of x by what? Can you tell me which piece? Which piece corresponds to values x greater than 1? X squared plus b, right? Look here. You see this one here. Okay, great. So this would be x squared plus b. And if we go further, this limit will be equal to what? Can you tell me? One plus b, exactly. Okay, great. And I also know that this is 5 as well. So now we have a system of 2 equations, 2 unknowns, right? Therefore, we have, so let's see, what do we have? So let's write it in this way: a plus 3 equals 5, and b plus 1 equals 5. So from here, this will imply that a is what and b is what? So a is, can you tell me, a is 2 and b is 4. That's it. Game over. That's the problem. Was it hard? So the only thing you need to use was just the definition. Let's see questions about this problem. Well, in life, there are things that we don't like, but we have to do them. So imagine that this is the situation here. You're not going to receive all problems that you like. So. Oh, wow, that's great. I'm glad to hear that. Let's see, why is it equal to 5? Because f of 1 is 5, you see? Right here. All these 3 things, this one, and this one must agree. Is it clear now? Bran? And others? So f of 1 is 5. Let's see. Yes, it is. Well, it is continuous for all x. In particular, it is continuous at the point x equals 1. And at x equals 1, the value of x at 1 is 5. As you can see here, the way it's defined here, right? Just look at this. At the end, we can do some of the homework. But first, I want to discuss the problems from the exam, and then we can do some from the homework. Oh, is it a similar one like this? It's continuous for for all x. Keep that, hold it a bit at the end. All right. Any other questions before I move on to the third problem? Let's see, no questions. Okay, let's move to the third problem. And the third problem says the following. I want you to look at it. It says pretty clear, find the derivatives of the following functions. And I think you had something, maybe not as hard as this in your gateway exam. So we have the following functions. The first function, f of x, is x to the power square root of x. And the second function is g of x is x to the power ln of square root of x. I want you to pay attention here. So think about it for a couple of minutes. So let's see. So can you look at these two functions, f of x and g of x? What do they look like? What is when you look at them, what do you see exactly? They're exponential, right? In fact, we have a power function to power another function, right? So what do you want to do here? What is that thing that comes to your mind when you would like to find the derivative of this? So how would you approach this? Power rule, use chain rule. Natural, exactly. So maybe we should use natural log. We see we have power to another function, power another function. So maybe we can use the logarithmic rule. Great. So what does this mean? And we have seen in class plenty of examples. So let's look at the first one. So f of x So take f of x. So let f of x be x to the power square root of x. Now take the log. So this means that ln of f of x is what? Is ln of x to the power square root of x. But now this guy, by the basic operations with the natural log, this will be what? As you can see here, this guy, square root of x, will come here outside the log. So this will be equal to what? To square root of x times ln of x. You mean square root of x, not x ln of x, right? Okay. Right, Jonathan? That's what you mean, I hope. All right, great. And now we know that ln of f of x is square root of x times ln of x. And now we take the derivative. Take the derivative on both sides. And we have what? And we have that ln of f of x prime is the same as square root of x times ln of x, everything prime. And now let's see. On the second one, what do we use? To compute the derivative of square root of x times ln of x, what do we use? Product rule, correct. So by using the product rule here, so what do we get? We get the square root of x prime times ln of x plus ln of x prime times square root of x. This would be the derivative of, so let's write it here. The derivative of the square root of x is 1 over 2 square root of x times ln of x plus 1 over x square root of x, or if you want, it's 1 over 2 square root of x ln of x plus 1 over square root of x, right? So that's what we get here on the right-hand side. Look here. All right, great. But here, this guy here, what do we use for this guy? Let's see, what do we use? I want to hear. So what is the derivative? E to the power x. What is the derivative of ln of f of x? We said this. What is it? One over f of x, and are you missing something? Oh, let me just charge exactly. So indeed, we have 1 over, yes, the derivative will be 1 over f of x times f prime of x. We said this, the chain rule. Remember, we said that ln of u prime is u prime over u, or 1 over u times u prime. So in our case, u is f of x, right? Remember we said this? Okay, so let's write this. So this is 1 over, oh my, I have to wait a bit to charge this. Unfortunately. So, as you can see here, well, let me just talk a bit before I, this will charge. And so we will get that this, the derivative of ln of f of x, right, prime, is 1 over f of x times f prime of x. And then we will see that this guy, so 1 over, this will imply that f prime of x over f of x will be the quantity that you see there on the right hand side, which is 1 over, on which one? On the one on the left hand one, you say, Brian? Yes, exactly. We use the chain rule on the left hand. Yeah, exactly. It's the chain rule. It's just, yeah, exactly. That's the chain rule that we're using here. So, since the beginning. No, not quite, because we have a, how do you use the chain rule there? So you have f to the power g, or u to the power v function. Yeah, you can use the chain rule, but you also, okay, hold up a bit. I'm gonna explain this at the end, but it will be, what you were saying, it's more complicated than the actual logarithmic differentiation, but I'm gonna hold that thought. We're gonna address it at the end of this exercise. All right, let's see. So this guy will be f prime, what's going on? Okay, sorry. So this guy will be f prime of x over f of x, which will be the quantity here on the right hand side, which is 1 over 2 square root of x times ln of x plus 1 over square root of x. Or if you want to factor, this would be 1 over square root of x times ln of x over 2 plus 1. All right, and now clearly, now f prime of x is nothing else than just f of x times this, times 1 over square root of x times ln of x over 2 plus 1. Well, if you want to write it, this will be, we know who f of x is, so it's x times square root of, to the power square root of x times 1 over square root of x times ln of x over 2 plus 1. And that's it. So that's the derivative right here, right? Okay, now let's see the second one. So the second one is, so we consider let g of x, this time is x to the power ln of square root of x. Okay, I want you to tell me, can we work this function out a bit so that we can make it look, I don't know, make it look better? Look here, the quantity here inside, this guy here. Can we rewrite this a bit? So what do you think here? Let's see. Maybe not quite x, maybe something else. So let's look at this quantity here separately. Ln of the square root of x. Can we rewrite this in a way? This is ln of, how can we write square root of x? As x to the power 1/2, right? And here, since we have the power here, we can bring this outside. So this will be equal to 1/2 ln of x, which is exactly what we want. So this would be x to the power ln of x to 1/2, right? And we can bring this 1/2 right here. So this would be x to the power 1/2 ln of x. So this is our function, in fact. So this is my function g, and now it's quite easier for me to do, again, logarithmic differentiation, right? So again, by taking the log, I'm taking the logarithm. And when I say logarithm, I mean natural log we get. So we have, let's see, what do we have? We have ln of g of x is equal to ln of x to the power 1/2 ln of x, right? So, okay, you see, now we can do more algebra here. You see, since I'm taking ln and I have x to the power this quantity, I can take this quantity out. So this would be what? Equal to 1/2 ln of x times ln of x. That's nice, right? Or which will be equal to what? 1/2 ln of x, everything squared. Great. Now we can take the derivative. So taking the derivative on both sides, we get, let's see, what do we get? Ln of g of x prime is 1/2 ln of x squared prime. Okay, tell me. Let's see, does this one, the second one, it will be equal to what? I want you to tell me. What do we use here? All right, the constant will go outside. I don't need to care about the constant, so, but I have here ln of x squared prime. And this will be what? So what do we use here? Somebody said something before. So some power, be more specific. It's a power, but you also have the function ln of x. Right? Exactly, the chain rule. So by the chain rule, right? So how do we use the chain rule? Let me write it here. With pink, I'm going to write it. So u squared of x prime is 2u of x times u prime of x. Right? So that's the chain rule, the version of the chain rule that we use. So in this case, our function u of x is, so in our case, u of x is ln of x, right? So by using the chain rule, let's see, what do we get? So this is 1/2 times what? Times 2 times ln of x times ln of x prime, which is 1/x. So that's what we're getting here on the right-hand side, right? I hope this makes sense. Right? And now, okay, on the left-hand side, we got that. Sorry, on the right-hand side, we got that. Let's see, what do we get on the, so on the left-hand side. So this guy here will be equal to what? Can you tell me? Ln of g of x prime is what? Come on, tell me. Ln of x over, be more specific, not quite like that. It's ln of g of x there, it's a function inside. Isn't it the same thing as previously? We had ln of f of x. Now I'm just going to change the function. It's g of x instead of f of x. So it's what? Guys, what is the derivative of ln of g of x? I just replace g by f by g. So it's 1 over g of x times g prime of x. Exactly. So in our case, so finally, right here, finally we obtain what do we obtain? We obtain that g prime of x is g of x times this thing over here, 1/2. Here 2 will go away, so in fact, let me write it. So this will be g of x times ln of x over x, correct? So this would be g of x in our case was what? Let's not forget who g of x was, x to the power, oops, sorry. So it's x to the power, if you want, ln of x, or ln of square root of x times ln of x over x. And that's the, in fact, let me write it. And that's your derivative. Boom, that's it. End of story. Let's see, any questions regarding this? Any questions? Okay, now let's move to the, I hope it's clear, you'll have something similar at the exam. Now, I want to move to the problem number 4. And problem number 4 says the following. So let me read it for you. It says, find the equation of the tangent line to the curve e to the power xy is x minus y at the point 1 of coordinates 1, 0. So the equation of the tangent line to the curve. That's what we need to find. And at this point. Yeah, you can use, I don't care the notation. You can use the d over dx. It doesn't matter. I use here prime, but you can use d over dx. I don't care about the notation. So you can use whatever notation fits, makes you feel better. I don't care. As long as it's correct. You can even write the derivative. You can invent your own notation. And I still don't care. As long as you know what you're doing. That's what I do care about. So think about it for a couple of minutes. So let's see. First of all, what do we need to know? What is the equation of the tangent line first? At a point, do you remember that? So the equation of the tangent line, let me remind you. So the equation of the tangent line at the point, let's say, of coordinates let's say x1, y1 is given by what? Can you tell me? I want to hear it. It's given by, let's hear it. Come on, tell me. Come on, please help me out here. You're taking the test tomorrow, not me. Well, I cannot hear you or see. Come on, what is the equation of the tangent line? Is what? Is given by y minus y1 is m times x minus x1, where m is what? M is the slope, right? Exactly, the slope. All right, so this is what you have in mind. So, and can you tell me what is the, so we need to find the slope, right? Exactly. So as you can see here, Eric asked the following question. So very good question, which says, do we have to do implicit differentiation to get the slope for the tangent line? Correct, exactly. And now to find the slope of the tangent line, right, we need to find this guy M here, right? This one. All right. So we need to perform implicit differentiation, right? So now we perform implicit differentiation to the curve e to the power xy equals x minus y. All right, let's do it. So now we have that. So let's see, what do we have? So d over dx of e to the power xy, right? So we perform implicit differentiation with respect to x. So, and this will be d over dx of x minus y. And now can you tell me, what do we get on the right-hand side? Tell me. So the right-hand side will be what? Let's see. You know, I'm talking only to Eric and a couple of you. So let's see. It's y dy dx. Not quite, Eric. Be careful here. So by applying the sum rule, we'll have d over dx of x, which will be something, minus dy over dx. This guy right here is equal to what? Equal to 1, exactly. So it's 1 minus dy over dx. Great. So we took care of the right hand side, which is great. So we have it right here. And now let's see what happens on the left hand side. So what do you think here? So this will be what? So this guy here will be equal to this guy, right? So you see, what do we have there? So it's e to the power xy, and we should be careful here. Really careful. So what do we have here if we take the derivative with respect to x? Let's see. Brian says chain rule and then product rule. Correct. Well, yes, exactly. So what do we have? So we have that this guy is e to the power xy, right? Times xy prime, right? So times the derivative dx, d over dx of xy. So here we use the chain rule. Remember, e to the power a function, right? Let me write it so that you guys can see it. I'm gonna write with pink. E to the power u of x prime is e to the power u of x times u prime of x. And in our case, u of x is xy, if you wanna. So that's what we use here. Okay, great. So this would be equal to, and now for this guy, I'm asking you, for this guy, what are we going to use? Can you tell me? So this is e to the power xy times, and now let's see, what do we do here? What are we going to do there? Come on, say it. Power rule? Come on, what is that? And inside, what is this guy here? This one here. Here, you look. X times y is what? Is a? What is it? It's a product. So we use the product rule exactly. So this would be what? So let's do it. Okay, I'm gonna write it with red. So it will be d over dx times of x times y plus x times dy over dx. So we use here the product rule. Okay, so this would give us, so this would give us what? So this would give us e to the power xy times this guy here, right? This guy here is 1. So this would be y plus x dy over dx. Okay. And now if we put everything together, so finally we have, so we obtained, so let's see, what do we obtain? So we obtain the following, that 1 minus dy over dx equals e to the power xy times y plus x times dy over dx. And by rearranging everything, by just multiplying everything, right, and isolating this guy here, dy over dx on both sides, what do we get? So this will be equivalent, and I'll leave this to you as an exercise. So we'll get what? Dy over dx will be, So let me do a quick computation. So it will be 1 minus y times e to the power xy over 1 plus x times e to the power xy. Okay, so we finally obtained this, which is great after we isolated. So now I'll leave this to you as an exercise to figure it out. All right, so now what are we going to do? Because we need to find the slope. So how are we going to find the slope? So the slope will be what? So the slope is, so let's write the slope m equals what? Is dy over dx. So it's dy over dx. Evaluate the point. Let's keep in mind what the point was. As you can see it here, it was this guy here, 1, 0. So it's evaluate the point 1, 0, which gives us what? Well, you can plug it in, x equals 1 and y equals 0, and we will get what? What can? Well, it's 1 minus 0 times e to the power 1 times 0 over 1 plus 1 times e to the power 1 times 0. This guy is what? Can you tell me? Is equal to 1/2, correct. All right, so the slope is 1/2, that's great. And now, since the slope is 1/2, we can easily write the equation of the tangent line. So finally, the equation of the tangent line. Tangent line is what? Is, let's not forget though, it's y minus 0, right? That was the point. Equals to the slope m, which is 1/2 times x minus 1. Or rearranging this will be what? Y equals 1/2 times x minus 1/2. And that's the equation of the tangent line. And that's the end of the problem, right? You see, once again, you have to know what the equation of the tangent line. Once you write the equation of the tangent line at the given point, you replace the given points. You know x1 and y1, you know who they are. And the only thing that's missing in our picture is the slope m. And for you to find the slope, the only thing you need to do is just to perform the implicit differentiation. And once you isolate dy over dx, you just plug it in the values at the given point for x and y respectively. And that's it. And then you write the equation just like we do here. Let's see, any questions regarding this example, this problem? So is the procedure clear? It's pretty standard, I would say. So the only thing I would, I see some people are laughing, but yeah, it's actually really standard. Like I said, the only thing you need to know is just to write the equation of the tangent line, and then you find the slope. And then to find the slope, you do implicit differentiation. And you need to be careful with that implicit differentiation, right? You're applying the chain rule, product rule. So that's the hard part of it, just to implicit differentiate the equation of the curve. But once you do that, everything will become pretty clear. No questions? Okay, if there are no questions, I'm going to move to a difficult problem this time. Look at it. This is, like I said, problem number 5 will be a difficult problem. This one will be tough. So it's a word problem, right? Related rates problem. Come on, don't be scared. Don't be too pessimistic. Just wait for the exam and after that. So let's see. You're sitting at X feet from a wall and watching a movie screen, which is 10 feet high and 6 feet and is 6 feet above the floor. This is important. Your viewing angle is theta radians. So you are asked to do the following. The first thing is write your viewing angle theta as a function of x. And the second one is, the second question is, if x is increasing at the rate of the 10 feet per minute, at what rate is theta changing when x is 8 feet? All right, so I want you to read the problem again to try to visualize it. And think about it for a couple of minutes. So let me just a second. Let's see, there was a question here. So the screen is 4 feet tall. Yes, exactly. That is the thing that you need to see. Wait. It's a bit tricky, the problem, I would say that. So it's a bit tricky. You need to draw the picture, the correct picture. And once you have the correct picture, then everything will be clear. Please read the statement carefully. This is important. So let's draw the picture first, right? The first thing that you do, and we said this in the lectures a couple of times, we said that before you even start, performing some computation or anything like that, the first thing that you need to do is to draw a picture. So let's see. So first, we draw a picture. And let's analyze together this. So you are sitting at X feet from a wall and watching a movie screen which is 10 feet high and is above 6 feet, 6 feet above the floor. So let's analyze these two. So we are sitting at X feet and we're watching a movie screen, which is 10 feet high and is about 6 feet above the floor. So we're sitting, so this is us right here, right? And so right here at this point, right at the floor. And now what we know that we're watching a movie screen. In fact, let me draw the larger, bigger picture. So this is because the picture is essential. So let's see. We're watching a movie screen which is 10 feet. So this guy is 10 feet here, the movie screen. This guy is 10 feet, right? And this is 6 feet above the wall. So this is 6 feet here. So this, okay, let me write this in. So this guy here, from here, is 6 feet, right? And the movie screen, right? So this is the movie screen. This guy here is 10 feet. Right? So that's the movie screen. All right, great. Great. And we're sitting there. So now let's look closely. So if we analyze this a bit, right? So let's see. Your viewing angle is a theta radians. So my viewing angle of what? Of the movie screen, right? So this guy here, so this will be my viewing angle of the movie screen, will be theta. And now, right? And I can write my angle of viewing of the wall. Let's say this is an alpha, right? Okay, beautiful. And now what we need to do is, first thing, we need to write our viewing angle, theta, as a function of x. So let's see. Who is my x? That is the question. Because I'm sitting at x, right? X feet from a wall. So this guy is x3 here, right? So this is x feet from the wall, right? So now let's write a theta in terms of x. So let me identify this. So this triangle here so that you can guys see it, but let me do it with another color. Okay, this is, let me identify the triangle here. First of all, this is a right angle triangle. It's 90 degrees, right? So I need to do something here. That's, and also let me look at this triangle here, right? We have two triangles. Also this one here, right? Look at it, this one here. So the question is that I want to write this guy, theta, in terms of x. So that's the tricky part. So how should we do that? So think about it. So we have this right angle triangle, and we need to see something about it. Okay, tell me, how many right angle triangles do we have? How many of them? Two. Correct, there are two of them, right? Exactly, one, the big one, right? This big one here, and the smaller one, right? Okay, great. All right. And you see, we know something. Can we relate in this? Let's look at the smaller triangle. So let me write. So let me look again. So let's look at the smaller triangle. The smaller right angle triangle. Let me draw it again. So it's here, and it's right here. So this is 6, and this is alpha, right? And this is x. All right, so let's look at the smaller triangle. What can you tell me? Can we relate x to alpha, for example, by something? So what do we know in a right angle triangle? How can we relate the two legs? Because you see, we have the two legs, but we don't exactly by using the tangent function. Great. So in general, let me write this. So we have that using the usual trigonometry, you'll have that tangent of alpha, right? Is what? Is the opposite leg over the adjacent leg. So that's what you need to know. Beautiful. In our case, it will imply what? That tangent of alpha is what? Which one is the opposite leg in our case? Is 6 over x. Great. So this means that alpha is what? Can you tell me? What is alpha here? If tangent of alpha is 6 over x, alpha will be what? Is what? I want to hear. This is the very first lecture that we did. So by taking the inverse, right, it will be arctangent, or the tangent inverse of 6 over x. So that's what alpha is. This is arctangent is the tangent inverse. All right, great. So we know who this alpha is, right? And now let's move to the, I would like to express theta. What can you tell me about theta? You see, unfortunately, the second smaller triangle is not right angle triangle. So we cannot do the same thing, but we can do something. We can look at the big triangle, right? So if we look at the big triangle, so by looking at the big right angle triangle, what do we get? Can we express tangent of, you see, this time we can express what? We can express tangent of what? Yeah, but okay, it's 6. Be more specific. Tangent of who is 16 over x? Exactly. So what do we have? So we have that. So let's look at the triangle. We have the tangent of theta plus, so tangent of theta plus alpha. Exactly. So it's a tangent of theta plus alpha is what? Is the opposite leg, which is 10 plus 6, which is 16 over x. Or equivalently, we can write a tangent of theta plus alpha is 16 over x. Great. So tangent of theta plus alpha is 16 over x, or equivalently, if we apply the, or equivalently, we can say that if we apply the tangent inverse here, we can say that theta plus alpha is arctangent of 16 over x. Or equivalently, we know who alpha is, or theta is arctangent of 16 over x minus alpha, which is equivalent with, let me write it this way, theta is arctangent of 16 over x minus alpha, and alpha is what? Arctangent of 6 over x. And great, we finally we managed to write theta in terms of x, right? So this is what we're asked to do in the first one. Now let's see the second one. So let's analyze it together. So we know who theta is. Let's look back at the problem. So think about it. So if x is increasing at the rate of 10 feet per minute, what is the rate? At what rate is theta changing when x equals 8 feet? So think about it just a second. So what should we do here? So what do we know? Let's analyze together. What is x? If x is increasing at the rate of 10 feet per minute, how we can translate this? Can you tell me? This guy here. How do we translate this? You see, it's a rate of change. The rate is increasing at the rate, so it's changing, it's increasing. So this means what? When you hear the word rate of change, you think of what? You think of what? What does this mean? How we can translate this? Is what? The derivative of x with respect to t, right? Because it's, you see we have minutes there, so it's with respect to time is what? Is 10 feet, so let's see. So the second one here, we know that dx over dt is 10, right? And we need to find, let's see, what do we need to find? Let's analyze. So we need to find at what rate is theta changing. So when you see the word at what rate is theta changing, so this means this guy here, it means d theta over dt. And at x equals 8. So we need to find what? We need to find d theta over dt, right? When at what? At x, when x equals 8 feet. All right, so that's what we need to find. So what are we going to do? We're just going to take the derivative with respect to t. Pay attention there. And now we will do implicit differentiation. So by the chain rule, so recall that. So let's not forget. So let's write here by the chain rule. Let us recall that that the arctangent of f of x, pay attention here, it's a function, prime, so the derivative with respect to x, it will be what? 1 plus f squared of x times f prime of x. right? That's the chain rule for the arctangent. Remember, we also keep in mind that arctan of x, the derivative with respect to x of this was what? Was 1 over 1 plus x squared. So this is just an extension of this. So now we're going to use this guy here. We know that theta, we can write theta, we can relate theta and x, right? All right, so once we do this, now let's take the derivative with respect to t. So let me call this somehow what star. So now differentiating star. So we're going to take the derivative. We get, let's see, what do we get? So we get the d theta over dt equals, now let's see, okay, let me write it like this, d over dt of arctangent of 16 over x minus arctangent of 6 over x. All right, beautiful. And now let's take care of this guy on the right hand side, and let's see, what do we get? So this would be equal to, so let's write it by d over dt of arctangent of 16 over x minus d over dt of arctangent of 6 over x. All right, great. And now let's see this one by using the chain rule. What do we get? So the first one here, this guy right here, will be equal to what? You see, we have a function there, f of x, which is 16 over x in our case. So it will be what? It will be 1 over 1 plus f squared of x, right? Which is 16 over x, everything squared, times, and now we need to differentiate with respect to t. So it's d over dt of 16 over x. Oh my. All right. Okay, minus the same thing here. So we have 1 over 1 plus 6 over x squared times d over dt of 6 over x. All right, so this guy here, as you can see, is this guy here. This one is this one, and this one is this one. All right, great. And now we'll do computations. Oh my goodness. Actually, I don't like computations that much. But anyway, so let's do this. So this would be by just doing some computations. Let's see. Anyway, I'm going to leave them to you as an exercise so that I don't need to lose any more time with this. At the end of the day, it will give you something like this. So let's see. So it will be x squared plus 16 squared. So it will be negative. Okay, so it will be negative 16 over. In fact, let me write it on the next page. So this is some computation. So this would be negative 16 over x squared plus 256 times dx over dt minus negative 6 over x squared plus 36 times dx over dt. All right, and we know who dx over dt is. Let's not forget that. It's right here, right? It's 10. And now we're just going to plug it in. So this guy is 10. So this will give us, so by plugging this in, and we know who x is, also x is 8, this guy is 8 here. And at some point, this will be negative, let's write it, negative 6 times 8 squared plus 256 56 times 10 minus negative 6 over 8 squared plus 36 times 10. And all this mess here will give us whatever, I don't know what it is, it's 0.01 radians per minute. Anyway, you can do this by using the calculator, I don't care, per minute. That's your final answer. That's the theta over dt. So let's write again. Finally, the theta over dt is 0.100 radians per minute. And that's your final answer. That's it. So that's the end of the problem and the end of the test. Yeah, how would you rate this problem? Is it a difficult one? Was it difficult? Very difficult, correct? Well, the last problem will be difficult. So you see, what you need to do here is you just need to look at this. You need to, once you have this relation, this guy here, right? Relation star, this right here, well, your life will be much easier, right? So what was I have a question, what was the difficult part? To get to this relation or starting from here? So what was a difficult thing to do? Was it more difficult to get to a relation star or the other way around? Well, the tangent, look, okay, so here we have a question. So let's see, let's answer the question. How did we even get tangent from? Okay. Yes, exactly, trigonometry. Trigonometry, my friend. So let's explain a bit about trigonometry. That would be pre-calc. Look at this right angle triangle, and I've done this trigonometry in one of my if you go to my video lectures or even notes, or even the notes that I send you, you will see everything done there. But anyway, let's recap. You see, this is a leg, this is a leg, and this is the hypotenuse. So Pythagoras, and let's write this. Let's say AB, the first leg is, let's say C, and the second leg AC is B, and BC is A. Let's reuse this notation. So Pythagoras says that the sum of the squares of the two legs is the sum of the square of the hypotenuse. So in other words, is A squared. Or let me write this, b squared plus c squared is a squared. So that's Pythagoras. But also you can express this angle. So let's say this is alpha and this is beta. You can express these angles or the trigonometric functions of these angles in terms of the legs and the hypotenuse, right? So for example, you can take the sine of alpha. Usually sine of alpha in a right angle triangle is the opposite leg over the hypotenuse. Hypotenuse, right? Right, we have this. Usually it's like this. And you can also write cosine of alpha is the adjacent leg over hypotenuse. And in our case, and you can also do the same thing for beta, but anyway, let me write it for alpha, and I think you can do it for beta by yourself. So in this case, sine of alpha, let's identify which one is the opposite leg. So the opposite leg is AC, which is B. It's B over A. What about here, cosine of alpha? Which one is the adjacent leg? So it's the one close to alpha. Is what? Is AB, which is C. So it's C over A. Well, guess what? Tangent of alpha, we know that. Tangent of alpha is sine over cosine. So in our case, this means that tangent of alpha is what? Sine of alpha, which is B over A, everything over C over A. Or if you want to put it like this, is B over A times A over C, or B over C. And that's your tangent. You can also express cotangent and so on, whatever. Right? And you can do the same thing for beta, for the angle beta. It's just the same thing. The only thing will be there instead of B will be, so how can you write sine of beta? Is AB over BC. AB is C, so it's C over A. So instead of B over A, will be C over A, and so on. And I think you can do it by yourself. Is it clear now, Brian? I think you're the one that. Brian, others? Is it clear now? Okay, that's great. Please go back to my first and second lecture from last semester. I've done the prerequisite there. And I said I'm not going to do it again. So I just did it because I recorded the lectures by myself. So I said, okay, let me just do a small recap. I'm sorry, man. Life is hard. What can I say? I'm sure you will have fun at the wedding, but you should have told me this before. So, but anyway, it's a wedding, so. You can also think while you're dancing there and having fun, you can think of the problems as well. Who knows? Maybe you get some inspiration. Sometimes it happens. Let's see, any other questions? And I'm sure the wedding in the US will not last like the ones in Romania or in India. In Romania, we party all night long. In India, they party like four days. Probably it's just going to be a couple of hours. Let's see, any other questions? Make sure you don't drink too much. I mean, I think you're under 21, so you're not going to do that. Let's see any other questions. I think Brian had a question regarding a problem. Brian, was it you, if I remember right, about that continuous function? You want to talk about it?
Yeah.
Okay, let's hear the statement. So, extra problem from Brian.
It was on the on what's it called, the homework.
Yes.
Yeah.
Tell me the statement. So let's hear the statement.
Find the value of the constant C that makes the function f of s continuous.
Wait, easy, slower. So find the values. The value or the values? Anyway.
The values.
Value, it's a plural.
The value.
Okay. Okay, the value of constant C. Okay, such that?
Find the value of the constant C that makes the function f of s continuous.
F of s, right?
Yeah.
Okay.
On negative infinity to infinity.
So on the real line, okay. And f of s is given by what?
And then f of s is, the first equation is function is cs plus 1. If s is negative infinity to 5, close bracket.
So it's a negative infinity to 5, 5 including or?
5 including.
Okay, so close bracket. Okay, and what else?
And then the second function is cs squared
S squared, yes.
minus 1.
If S is 5 infinity, right?
Yeah.
So it had this problem, this function has two pieces, correct?
Mm-hmm.
All right, let's see. So what did we say at the beginning? What does this function, so we know that the function is continuous, right? Let's see, somebody says here something, Karen? Yes, exactly, we have to, yeah, so the function is continuous, right? Look here. So we know that the function f of s is continuous on the entire real line. In particular, so we know that the function f of s is continuous at the point 5, right? Continuous at the point s equals 5. Right, look at it. This is the point that we are dealing with. So we need to take care of this guy. And what do we know by the definition? So we know that also we know that f of s is continuous at s equals 5 if what? If and only if what? Can you tell me? We did this today. The lim as x approaches 5 from the left of f of s, oh, sorry, s, not x this time. As s approaches of f of s is the lim as s approaches 5 from the right, so of f of s, and it's also the value at 5. Okay, so these three must be equal. First of all, you see, what is the value at 5 of f? At s equals 5. What is it?
cs plus 1.
Is what? Where do you find the value? Where is the value s equals 5 included? In which of the two pieces?
It's the first one, right?
The first one, because it's a bracket there, right? It's in, so it will be what? F of 5 will be 5c plus 1, right? We're just going to replace s by 5. Great. And now let's look at this one here. What is this one? The limit as s, let's see, the lim as s approaches 5 from the left of f of s. I'm going to replace f of s by what? So these are values s which s that approach 5 from the left, which means that are values of s which are less than 5. Which of the two pieces I would put?
Second one.
Why the second one? Because it's are the values for which, well, let's translate this a bit. Look, this guy here means s approaches 5, s less than 5. Which one is less than 5 from these two pieces?
It's the first one.
The first one, exactly. So it is, and we're going to replace s by 5, so it will be 5c plus 1. Right? Great. Now let's look at the second one. The lim as s approaches 5 plus of what? And keep in mind that this guy here means that this is x approach, sorry, not x, Jesus Christ. Lim as s approaches. So this means what? This guy means that this is s approaches 5 with for values s greater than 5. So I'll put what inside? Tell me, look at the function. Which piece, which of the two pieces fits into the picture?
Second one.
The second one, and I'll replace s by 5. So it will be 25c minus 1. And all these are equal to 5c plus 1. Okay, and I think now you see also the value of 5 corresponds to this one. So finally, we get, so let's see, we have what? 5c plus 1 equals 25c minus 1, which will be equivalent. C is what? What is C here? It is 1 over 10. And that's it. That's the end of the problem. Is it clear? So we have 20c equals 2. 2 over 20 is 1 over 10. You see, it was very easy. The problem was pretty straightforward. And I think all of you, I hope you will agree with me, right? Very easy, right? Yeah, I hope that it will be like that for each and every one of you. All right, so as you can see, the last problem was the more difficult, right? And that's how the test should be like. So the last problem should be more for those who want an A+, and the other ones should be more standard, so that anyone who puts some effort into it will get it. We'll do the. Ladies and gentlemen, let's see. There was a question here. Let's see the question. Yes, there will be no question. I'll award partial credit. If you write relevant things, partial credit will be awarded. Definitely. Definitely. Yes, if you got, yes, I will award partial credit. But make sure you write details. If you don't write details and you're just going to write the answer, I'm not going to give you credit. Or maybe just small credit. So the way, as you can see, the way we wrote the review session, that's the way you should write the test. Let's see, are there any other questions? Let's see. At what time does it start? At midnight tonight. So you will see it on my website. You will receive an email with precise instructions on how to take the test, what to do, and so on. How you will send it back to me and everything. So be patient. Wait for my emails. Let's see some other questions here. Yes, exactly. You will need to scan. Yes, you will need to scan the test back as a PDF file. But just you will get these instructions. This will be the instructions that you will get. But roughly, this is what you have to do. You need to scan it back the way it was sent and send it back to me. And anyway, the details will be in the email. Are there any other questions? Yes, we still do have a lecture tomorrow, correct? Yes, yes, we do have a lecture tomorrow. That will take a little bit of your time, but anyway, I'm sure you can afford losing a little bit of your 1 hour and 20 minutes. Not even 1 hour and 20 minutes, maybe a bit less than that. And I don't know, I remember somebody was saying about going to a wedding. Dude, I've never heard about weddings on Monday. That's the first one. For me, that's crazy. You're the first person who tells me that there's a wedding on Monday. Wow. I heard about weddings on a Thursday or Friday or even Saturday or even a Sunday, but on Monday, that's quite a first. Let's see, any other questions? Congratulations to your sister. So in any case, it's a big event. Let's see, any other questions? If you got an 82 on all the homework, yes, so far you're in good standing for an A, for full credit for the homework. So at the end of the, I will upload other 3 homework sets, and they'll be due at the end of May. So if you get the average over all 6 of them to be greater than 80, then you get full credit for the homework. Let's see, any other questions? Well, if there are no other questions, ladies and gentlemen, thank you very much. I wish you good luck tomorrow on the test, although some of you who are night birds can start doing the test even tonight. Wait for it. Well, if I finish it earlier, I can send it to you earlier. I don't know, maybe around like 11 p.m., whatever. And you can start the test earlier. And I'll see you tomorrow at the lecture, right? Okay. Take care. Bye-bye, and I'll see you tomorrow. And good luck. Bye.